So thank you very much, Chair. A very good evening to all of you. I'm very delighted to be here, and first of all, I would like to thank KACC for giving me this opportunity to be here. And this is the first time NAMCC is attending the ACM meeting. Last time also I tried, but due to some problems, I could not attend the ACM meeting in Thailand. So, and then I would like to also congratulate KACC on its 30th anniversary. So before I start my talk on fostering agriculture sustainability in India, culture repositories in microbial product research and market innovation, just let me introduce my organization. I will just take a minute for that. So I basically come from Indian Council of Agriculture Research, which is the major or the main research and development organization under the Ministry of Agriculture and Farmers Welfare. And among more than 100 institutes under Indian Council of Agriculture Research, we have 6 national bureaus which are basically involved in the conservation of biological diversity in the country. So we have national bureaus for animal, fish, insect, plants, as well as for microorganisms. And I am from the bureau working on the microorganisms. And national agriculturally important microbial culture collection is a part of NBAIM. So as you know that India is a very big country and the population is about 1.4 billion, and to feed this many people, we need a very huge amount of crop production. And since the Green Revolution started in our country during the 1970s or 1960s, our research system has developed mostly high-yielding varieties, which are responsive to huge amount of chemical fertilizers, as well as due to the requirement of chemical fertilizers, they were prone to diseases and pests, and we had to use a large amount of agrochemicals also. And this is one of the reasons why the soil has degraded in India, and you can see here about 30% of the land in India is degraded, or its productivity has gone down because of many factors involving the application of fertilizer, pesticides, salinity, sodicity, lack of water resources, acidity. All these things are basically ultimately impacting the productivity of the agriculture system in the country. So gradually we are now shifting towards a sustainable agriculture, and in sustainable agriculture, regenerative farming is one of the important practices which can help the soil to retain its health or to sustain it in a better way. So gradually, the focus of the government of India is going towards regenerative farming. We have in our country initiated different programs, government programs on regenerative farming, on natural farming and nature-friendly farming. So on these regenerative farming, microorganisms are an important part, as you know. So in India, the microbial products which are used in agriculture system are basically categorized in biopesticides, biofertilizers, and biostimulants. And biopesticides are regulated by the Insecticides Act 1965, and we have a quite a good amount of biopesticide production. You can see here in 2021 to 2022, it was about 9,321 million tons of biopesticides we produced. And the biofertilizers are regulated by the Fertilizer Control Order 1985, and about 10 different types of biofertilizers are permitted in India, which includes nitrogen-fixing bacteria, phosphate-solubilizing bacteria, zinc-solubilizing bacteria, mycorrhiza, and some others. And biostimulant has been approved very recently, and it is again regulated by the Fertilizer Control Order 1985, and Schedule 6 of this FCO 1985 is regulating the biostimulants. And as Dr. Maron has already told that there are lack of awareness among the biopesticides and biofertilizers all over the world, I fully agree with her. And besides that, there are certain other issues which I would just like to highlight. Like you can see here that biopesticides and biofertilizers, when the term pesticide and fertilizer is there, in these particular terms, then these goes to the laws or regulations which are actually regulating the chemical fertilizers and chemical pesticides. So this is basically in India a major hindrance in popularization of the biopesticides, because we don't have that many biopesticides which are registered in India, as well as the biofertilizers also. The regulations are not very clear. So the production also in case of biofertilizer is not very much, because there are certain issues in the regulation as well as the availability of the authentic microbial cultures. Now with the availability of good quality cultures from different microbial culture collections, we are going forward. So this is just an overview of the Indian biofertilizer and biopesticide market. In case of biofertilizer, the market value of biofertilizer was about $10.63 million in 2024, which is expected to rise to $16.50 million by 2030. And in India, as it is a very big country, the utilization of the biofertilizers or biopesticides, or the production of the biofertilizers or biopesticides, are also very skewed. If you see the different parts of India, the major biopesticide and biofertilizer producing units as well as the consumers are located in the western and southern part of the country. Because the farmers over there are little progressive, and they are ready to accept the new things very easily. So the production of the biofertilizer in India is basically undertaken by government-funded production units, universities, ICAR institutes, and also the private industries. And some of the major industries in India are International Panacea Biologicals, United Phosphorus Limited, Novozymes, T-Stains. And in case of biopesticide, the present value of the market value of the biopesticides in India is about $240 million, which is expected to rise to about $381 million by 2030, with a CAGR of about 9.5%. And again, some of the major biopesticide producing companies are Coromandel, IPL Biological, T-Stains, and Ken Biosis. So basically all these private organizations or government R&D funded labs, they are using the indigenous microorganisms for the production of biofertilizers. You are aware that India is a very biodiverse, highly biodiverse country, and we have 4 biodiversity hotspots like Himalaya, Indo-Burma region, Sundaland, and Western Ghats. So you can also look at this table, although it is a little old information, but you can see that about 10 to 20% of the microbial diversity which has been described till date belongs to India. So all these microbial diversity are being conserved by, basically majority of this microbial diversity is being conserved by these 4 culture collection: microbial type culture collection in Chandigarh, National Center for Microbial Resources in Pune, our culture collection, that is NAMCC, and Indian type culture collection. Indian type culture collection is one of the oldest culture collection in India, and they specialize in conservation and application pathogenic fungi, plant pathogenic fungi, as well as the biopesticide fungus. India, I think this data is of 2023 or 2024, is among one of the top 5 microbial accession holders as per the WDCM information. So how these Indian culture repositories are helping the bioagri input industries? You are aware that any industry which is going for bioproduct development, like Dr. Maron has told that she has, at some point of time, she has screened about 55,000 microbial cultures for some of the products. So basically industries need a very rich and very huge microbial resource pool for screening. And obviously for once you have isolated some potent culture, you need some reference strains to compare with for the functional attributes. And for commercial production, you need pure culture, genetically stable culture, and definitely the efficient culture. And obviously in countries like India, we need we have to meet some regulatory compliances, and for that, the cultures must be deposited in a designated repository, which is actually an approval from the National Biodiversity Authority under the Indian Biodiversity Act. So besides that, intellectual property is an important issue in commercial production. So for intellectual property protection also, one has to deposit the culture as a safe deposit or a patent deposit. So in all these aspects, the culture repositories can help the bioagri input industries. So I have just listed out that how these culture repositories are helping in development or commercialization or innovation of the microbial bioinputs. Like you can see here, in case of nitrogenous or phosphatic or potassic biofertilizers, MTCC, NAMCC, and MCC are the major mother culture suppliers. And in case of biofertilizers for sulfur, zinc, iron, although sulfur, zinc, iron has not been approved by the government of India yet through any regulation, still some of the companies are producing this kind of biofertilizers and are in use in our system. The major supplier of these cultures are NAMCC and MTCC, and for biopesticides, the major chunk comes from the Indian type culture collection, MTCC, NAMCC, and MCC. And for agro-residue degradation in India, agro-residue is a huge problem. I just like to inform you that there are some states in India who after rice production, they will burn the rice stubbles, and which will create a huge pollution problem. So for that, nowadays there are huge demand for agro-residue degradation in India. So for agro-residue degradation, we have a huge collection of lignocellulosic fungi in our collection. So we are the supplier of agro-residue degrading fungus. So I mean, I'm very inspired with the lecture by Dr. Maron. So I am again going to quote her. Like she told that unmet needs. So there are certain unmet needs also in case of Indian agriculture system, especially in case of the microbial inputs. And you can see here that there is a increasing demand for nematode controlling agents, microbial nematode controlling agents. And I was talking with some of our friends during the lunch that in India, the climate variation has become very severe. The rainfall has become very erratic. The temperature is shooting like anything. So, and the water resource is also declining. So we also need some kind of microbial formulation which can help plants to cope up with the water stress. With the climate change, the GHG emission, especially in case of methane, it is very important to have some methanotropic bacterial formulation. And I am glad to inform you that some of our sister institutes under Indian Council of Agriculture Research, they have already developed some commercial formulations based on the methanotropes. And pesticide degradation is also very important because as in India, in many of the exportable products, the pesticide is being used, and those products at many point of times they are rejected by the different countries. So there is a very unique example of grape export. We have an institute at Pune, National Research Center on grape. They have developed a very unique microbial bioformulation, which if applied on the grape, they can degrade the pesticides. And as a result, the grape export has increased many folds in India. Also, endophyte is in demand, endophyte cultures, and microbial consortium, although Indian government has permitted the consortium of nitrogen, phosphorus, and potassium mobilizing bacteria, but still there are demand from the industries to develop more number of microbial cultures in a single formulation, or more number of biological traits in a single formulation. Also the microbiome-based formulation, although this microbiome-based formulation are in its nascent stages, because our regulations, particularly for the quality control, is not quite ready for the microbiome-based formulations, because as one of our colleagues asked that whether microbiome-based formulations can be used or not, or it can be regulated or not, it's really very difficult. We had an opportunity to work with a private company for some time who were working with a microbial formulation containing 75 different bacteria. But still it is stuck on the regulatory clearances. So our organization supports the private industries through the consultancy and contract research with the for product development and validation also. And not only the private industries, we also cater some of the very reputed science and technology institutes like Indian Institute of Technology, Indian Institute of Science and Science Education and Research in India for developing microbial products. So I'm just going to give an example how our repositories are basically helping the biopesticide industries. You can see in this table that total 64 microbial bioinsecticides are registered in India, and 32 microbial biofungicides are registered in India. And out of these, in case of bioinsecticide, about 17% of the mother cultures are derived from ITCC, and 9% cultures are derived from MTCC and NAMCC, and altogether about 43% of the cultures can be traced back to one or the other microbial repository in India. And in case of biofungicide, about 69% of the cultures can be traced back to one or the other microbial culture repository. Let me tell you, the market value of the biopesticide industry in India is about $240 million US. Conservatively, if we consider that 40% of the microbial cultures are being supplied from these 4 repositories, then these 4 microbial repositories are basically contributing in about $100 million economy in India. So I would take a very brief opportunity to introduce our culture collection. So our culture collection conserves bacteria, actinomycetes, cyanobacteria and fungi, and conserves only the BSL, biosafety level 1 microorganisms, and doesn't conserve any virus. And ours is an international depository authority which was recognized in 2020. And very importantly, ours is the only international depository authority in India which accepts cyanobacteria and microalgae as a patent deposit. And we have in India one of the largest collection of Streptomyces, Trichoderma, Fusarium and cyanobacteria. So the major facilities of NAMCC are freeze drying facilities, we have cryopreservation facilities, we have cyanobacterial culture room, microscopic facilities like scanning electron microscope, confocal laser scanning microscope we have, and we also have all sorts of facilities for molecular identification of the microorganisms. NAMCC basically offers 2 kinds of services. One is paid services and another is free of cost services. In case of free of cost services, we have general deposition, and another important aspect is registration of elite microbial germplasm. Indian Council of Agriculture Research initiated this particular registration of microbial germplasm in line with the plant microbial germplasm registration, where one can register the novel microorganisms with novel functional properties with NBAIM or NAMCC, so that they can have a soft IP protection over that particular culture until and unless that particular culture is commercialized in the market. So among the paid services, as the other cultures collections are doing, we are offering patent deposition, safe deposition and supply to the cultures. And our major stakeholders are government funded R&D labs, colleges, universities and private industries. So at present we have about 9,500 microbial cultures, of which about 4,031 is bacteria, 4,607 is fungus, and about 412 is cyanobacteria, and all of these microorganisms are isolated from different agroecological systems of India, starting from cold desert to hot desert, from the high altitude lakes to marine environments. So we have a core collection of the microbial cultures. We have named it a core collection because there are certain microbial cultures which are very important pathogens, which are having very important functions to play in the agriculture systems, and some of the cultures are very frequently supplied to the stakeholders. So this is just a list of some of the cultures which we are having in our core collection, and we are having a very rich source of biocontrol agents, about 965 biocontrol agents we have. We have a very rich source of PSB, siderophore producing microorganisms. And just to show you how NAMCC stands, although our culture collection is not very big culture collection, but still it, in case of some of the agriculturally important microorganisms, it stands in top 5. Like in case of, you can see that Trichoderma viridi, we have, as per the WDCM data, we have the largest collection of Trichoderma viridi. In case of Metarhizium also, similar is the case of Beauveria, Bacillus thuringiensis, in Fusarium, Alternaria, Azotobacter. So these are some of the industry stakeholders of NAMCC. You can see here that some of the global players like UPL, Valagro, Zytex, they are also stakeholders, or they are taking services from our culture collection. So I think most of the things I have already told. So I'm not going to explain this slide. So I've just finished my talk with a very brief acknowledgement to my parent organization, Indian Council of Agriculture Research, our director, all staff of the NAMCC and Korean Agriculture Collection, Rural Development Administration of the Republic of Korea. I will end my talk with a very important statement which was given by Professor M.S. Swaminathan, who is regarded as the father of Indian Green Revolution, that if conservation of natural resources goes wrong, nothing else will go right. Thank you very much.